This fundamental note, this one was.
No, ma'am. It is about finding the speed and yeah, it is about finding the speed.
Have we completed all these?
I don't think so, ma'am. No.
Right?
No, ma'am. We haven't.
We haven't. This, so did we start at least with this third one, a metal of wire of
No,
linear mass? We
we
didn't
were
start.
doing just 1 second now.
I think we're in the second question, ma'am. Yeah.
Second is over. Now this one has to be done, right, boys? We'll start with it.
No, I think we were discussing the second question.
Second was over. This one.
Yes,
This
ma'am.
one
This one.
textbook.
Yes, ma'am, we are doing
Have we
this one.
completed? Okay, then yeah, one second. I thought I'll finish our oscillations today.
Yes, ma'am. We completed this.
We go for the third one. Okay, boys. A metal wire of linear mass density, that is mass per unit length. 9.8 gram per meter. You have to be careful, boys. Gram should be converted to kilogram. So, a metal wire of linear mass density 9.8 gram per meter, which is 9.8 to the power of minus 3 kilogram per meter, right? The tension in the wire is 10 kilogram weight, which is equal to 10 into 9.8, 9.98 Newton. And the length of the wire is 1 meter. Then find the frequency of the alternating current, because this wire is connected to your alternating current. The current makes the string to vibrate. Now at one point at resonance, your string is going to vibrate with a frequency equal to the alternating current. So if you find the frequency of the vibrating string, that will be equal to the frequency of the alternating current. Boys, you have a string. One end of the string is attached. The other end of the string is moves over the pulley and it is attached to a weight, so that this string is under tension. Now, what happens is that you are passing the current through the string, alternating current through the string, and this string is kept between the pole pieces of a magnet. So you have learned in grade 10, a current carrying conductor when placed in a magnetic field will experience a force and begins to vibrate. So now the spring begins to vibrate. The spring begins to vibrate with a frequency. It begins to vibrate with certain frequency. When the frequency of the vibrating string becomes equal to the frequency of the alternating current, the alternating current is the current which we draw from our mains power supply, that is 50 hertz. So if the spring vibrates with a frequency of 50 hertz, then we hear a very sharp sound. We call that as the string is under resonance. So now the question, find the frequency of the alternating current. The frequency of the alternating current will be equal to the frequency of the vibrating string. So you have to find the frequency of the string. That gives you the frequency of the alternating current. So you have the formula, boys. Nu is equal to 1 by 2L root of T by M. Tensions given in kilogram weight, you have to convert it to newtons. Multiply with 9.8. The length of the wire is 1 meter. Mass per unit length is given in grams. You convert it to kilograms. Boys, you're not supposed to use your calculator, but since we have to solve more numericals, if at all you can use your calculator so that I'll finish the work faster. But in board exams, you are not allowed to use your calculator. Right now, to complete more numericals, I just ask you to just do it fast. So this is a mere substitution, substitute. Just check whether your frequency is 50 hertz Is that your frequency 50 Hertz? Lemonby, are you calculating? 11th standard?
Yes, ma'am, it's 50 Hertz.
Only few boys are.
Ma'am, just a minute, I'm not checking.
Okay, okay.
Ma'am, this is a textbook question, right?
No, this is not the textbook. The first two were textbook questions.
Okay, ma'am.
So can
Shall
you
I
please
move?
upload this PPT
Yeah.
on the team?
Okay, fine. Shall I go for the next slide, boys?
Yes, ma'am.
Calculate the fundamental frequency of a sonometer wire of length 20 centimeter, tension 25 Newton, cross-sectional area 10 to the power of minus 3 centimeters square, and density of the material is 10 to the power of 4 kilogram per meter cube. Sonometer wire means the experiment in where a string is attached, one end of the string is fixed, the other end is under tension. You are attaching it to a weight. So such a stretched string is capable of vibration. And this entire setup, we call it as sonometer. So now the question is, you have a string, the string is having a length of 20 centimeter. Now it is, you are applying a force of 25 Newton, which means the string is under tension of 25 Newton. The thickness of the wire is 10 to the power of minus 3 centimeter square. The density of the material of the wire is 10 to the power of 4 kilogram per meter cube. So it's like you have to find the frequency, fundamental frequency of the transverse wave which is passing over the wire. This wire is a stretched wire because it is stretched under tension. So this is the formula. Nu is equal to 1 by 2L root of T by M. Now the question is, boys, the tension, the value of tension is given as 25 Newton. The length of the wire is given as 20 centimeter. What we need to find is the mass per unit length. Are you clear, boys? The length is given as 20 centimeter. You are converting it to meter. 20 into 10 to the power of minus 2 meter. The tension is given as 25 Newton. Then what else is given? The area of cross section is 10 to the power of minus 3 centimeter squared, which means 10 to the power of minus 6 meter squared. Centimeter squared, I'm converting it into meter squared. The density is given as 10 to the power of 4 kilogram per meter cube, right? Your aim is to find what is mass per unit length. Clear, boys? What is M is mass per unit length? It is not just mass of the string. It is mass per unit length of the wire. What is the mass of the wire for 1 centimeter? What is the mass of the wire of length 2 centimeter? That is what we call it as mass of the length per unit wire. Now, you know density is mass per volume. The density is mass per volume. So what is volume? Volume is area into length. Are you clear, boys? So density, the value is 10 to the power of 4. Mass, area is given. So I'll take area to this side. Boys, is that clear for you? Or should I erase and do it once again? Should I erase and do this?
Ma'am, it's clear. Ma'am, it's clear.
Okay. So area into density, boys. Here, I'll just, if you find it difficult, I'll just put still density. So area into density. This is density. So area into density gives you mass per unit length, because area goes, it becomes mass per unit length. So substitute the value of area 10 to the power of minus 6, density is 10 to the power of 4. So mass per unit length on right hand side becomes 10 to the power of minus 2 kilogram per meter.
Ma'am, so the final answer is 125 hertz?
Yeah.
Okay, ma'am.
So calculate, boys. Now you substitute and find. So mass per unit length will becomes 10 to the power of minus 2 kilogram per meter. Now you are getting mass per length. That is what we just denoted it as m. That becomes equal to 10 to the power of minus 2 kilogram per meter.
Ma'am, when we were writing the exam and it gets confusing between mass and mass per unit length, can we write in the equation T by M by L?
No, you can write mu.
Capital M. Mu,
So
okay.
mu becomes equal. Generally we go for mu, but I don't know whether since you have not been introduced to this factor, we have just taken as you go for mu. Mu is m by L.
All right, ma'am. Okay.
Mass by L if you're finding it. So have you calculated others, boys? Boys, it will be very tough when you
Yes,
go
ma'am,
for your
got it.
examination.
125.
So anyway, next. I'm just going through this question. A stretched string emits a fundamental note of 256 hertz. So you have a stretched
Ma'am?
string. Yes.
Ma'am, can you show the previous slide for me? Yes,
You
ma'am.
want me to put in the chat box?
No, ma'am, it's fine.
It's there.
Voice, I'll just go for it. A stretched string emits a note of 256 hertz, that is fundamental note. So the frequency of the fundamental note for the stretched string mu is equal to 1 by 2L root T by M. What is the value? 256. Now what is happening is keeping the force a constant. Stretching force means the tension a constant. That is what it means. Keeping the stretching force is your tension. Keeping the tension a constant, reducing the length of the wire by 10 centimeter. Can you see this? The length of the wire becomes L minus 10. Then the frequency of the vibrating wire becomes 320. Whereas in the first case, when the length of the wire was L, tension is T, mass per unit length is M, the frequency is 256 hertz. Now, the tension is kept a constant, mass per unit length is also kept constant. What is changing? T is kept a constant. Only your L changes is get reduced by L minus 10. When such thing happens, your frequency changes from 356 to 320 hertz. Now they are asking you find the original length of the wire. Original length is L. So what you do is you divide equation 2 by 1 and find the value of L. Do you understand the question?
Ma'am, root of T by M, is that the stretching force constant?
Yeah, so when you divide this factor, root of T by M gets cancelled. So it will be 320 by 256. L by L minus 10, then cross multiply. Divide equation 2 by 1, then the factor root of T by M gets cancelled. What is the value of L? Ayush, sorry. What is the value of L? Just
Ma'am, is it 10 raised, sorry, yeah, 10 centimeter, and then if you have to convert that to meter, right, ma'am?
1 second, boys. Is it not 50 centimeter?
Sorry, ma'am.
Wait.
Yeah.
50, should I do?
No, ma'am.
Should I divide equation 2 by 1 and then cross multiply? If someone wants me to do, I will do that numerically. Should I do? Are you getting this value LS 50 centimeter 50? Have you completed?
Ma'am, can you do this question?
Yeah. But you know how to calculate, right? I'll go for the next one.
Yes, ma'am.
Okay. Boys, please understand, when you consider your organ pipes, where one end is closed, the other end is open. Just write these formulas, boys. The fundamental frequency of one end closed open-ended pipe, which means you will have a node at the closed end and node at the open end. So the fundamental frequency nu is 1 by 4L root of gamma p by rho. If the pipe is open at both the ends, then the first harmonic or the fundamental frequency is 1 by 2L root of gamma p by rho. Write this and then
Ma'am, could you please show the previous slide for 1 second? Thank you, ma'am. Ma'am, you can change the slide. I've put it in the chat.
just like the basic formula. Shall we go for the next one, was?
Yes, ma'am, I put this slide in the chat box.
1 second. These relations, if you can know. For if I go for organ pipe closed at one end, pipe open at both the ends. And those here, your first fundamental note, first harmonic. Because if you know the relation, then it will be easy for you. First harmonic, nu1 is equal to 1 by 4L root of gamma p by rho. Or I can write nu1 is equal to 1 by 4L into velocity. First harmonic, this is fundamental frequency. This is what we call it as a velocity of the wave. Then the second mode of vibration, there your nu2 sorry boys, sorry, this is 2L. There is the organ pipe open at both the ends. Was that the previous one also? I gave the same thing. I have not made any change, any.
You made
any
you wrote 1/2L there
Where?
in the previous one.
Previous one for open. One second, boys. Both ends open, correct? 1/2L, correct? Correct, right? So when this organ pipe open at both the ends, the second mode of vibration, your nu2 will be equal to 2 times nu1. This frequency we call it as second harmonic, or we call it as first overtone. So I can call this a second harmonic or first overtone. Now, why these relations are important? Only thing is that you should know what is nu1, that's it. Then third mode of vibration. Nu3 will be 3 times nu1. So this we call it as second harmonic, or third harmonic and second overtone. Second. So these basic relations you should know, boys. Nu2 is 2 times nu1. Nu3 is 3 times nu1. Nu1 is 1/2L into V. Tomorrow, please learn this formula for organ pipe open at both the ends. I have just completed. Just learn the formula for organ pipe closed at one end, open at the other end, so that I can just finish few numericals over there here, and then I can start with oscillations. Boys, otherwise it will become difficult for you to sit at home and just practice all these things. So fundamental things I'll do it in the class. So tomorrow, do you have any test? Do you have any practical test? Is it over?
No, ma'am.
Tomorrow, do you have a test?